So we have completed the first part of multithreading. Okay, we have seen all about there is to see about threads. Okay, we have introduced the threads, how we will define the threads, what are the main functions in my thread class. We have seen all that. Now we will see a topic known as synchronization. Okay, now till now we have just seen one or two threads working independently. But what happens, we are not completely independent when they are not completely independent. So before that, let's see a good topic of operating system, that is the race condition. This is a very famous example of the race condition. I will explain you what race condition is if you haven't heard of it. So here what we are doing is, suppose this is thread 1 and suppose this is thread 2, and this is the job of thread 1 and this is the job of thread 2. Then now the problem is they are not completely independent of each other. They are both using a shared variable known as count. They are both using a shared variable known as count. One is incrementing the value of count, another is decrementing the value of count. And starting, for example, the count value is 5. Okay. Now count plus plus inside our assembly language is written like this. First, the count value is given to some random a register. Okay, so R0 will contain the value of count, that is currently 5. Then R0 will be incremented, so it will become 6, and again 6 will be given to the variable count, so count will finally become 6. Okay, same here to R1, what 5 will be given, then decrement 5, so it will become 4, and this 4 will be given back to count, so count value will finally be 4. So for T1 the count value should be 4, and for T2 the count value should be 4, and for T1 the count value should be 6. But the problem is there is T1 can access count plus plus and T2 can access count plus plus simultaneously. Okay, there is no condition that is stopping them. Okay, so the shared variable can be accessed by both T1 and it can be accessed by T2 simultaneously. Let's see what is the problem. So if there are 3 steps, correct? So if T1 is the one who first accessed count variable plus plus, so what is happening here? So the first step is complete and the second step is complete. So if 2 steps are complete, my R naught will be nothing but 6, my R0 will be 6, and the count still be 5. In the 2 steps, the R0 will be 6 and the count will still be 5, and it got preempted Okay, it got stopped. Now T2, now scheduler schedules T2. Now T2 does all the 3 steps. So what it does, count value is currently 5, so all these 3 steps it executes. So 5 will go to R1 will decrement it, and it will return back to count. So count value now becomes 4. So for T2 the count value is 4 and it has completed all its steps, so it exits. Now T1 is still remaining, so what it does, it simply, so the count value becomes 4. Now what it does, it simply performs the last step. So what is the last step? So current value of R naught, just give it to count. So current value of R naught was 6, it will give it to count, so the count value will become 6. But now T1 will access the count value and he will see, oh, but the value should have been 4, but the value is 6. For T1 the answer is correct, but for T2 the answer is wrong. This is known as data inconsistency problem. Okay, now let's see one more scenario. For suppose T2 got this first and second, so R1 for T2, so that means the R1, that is the register, will contain the value of 5. Okay, let's begin from the starting. So count value is 5. Now T2 gets 1 and 2 and 3, all the 3 steps, so the count value becomes 6. Okay, it increments. So for T1 the count value becomes 6, it increments. Now T2 will get the last step. When T2 gets the last step, it will decrement it to 4. So now for T1 the answer should be 6, but the answer is currently 4. So again there is a problem. So what is race condition? When the output of your program depends on the execution order. So in this order T1 gets first, in this order T2 gets first, so it depends on the execution order, then this type of condition is known as the race condition. Okay, so this is known as the data inconsistency problem. Why? Because if I have an object, and now I am coming back into Java terms, if I am an object, okay, and both T1 and T2 are simultaneously accessing this object, okay, till T1 and T2 are completely independent of each other, there is no problem. But if I have a method, or if I have a shared variable known as count, and both are updating it simultaneously, then there will be data inconsistency problem. Okay, if T3 also comes, then the data inconsistency problem will increase. Fine. So because there is no mechanism till now that we are not stopping this T1, T2 and T3 to access the shared variable simultaneously, therefore this data inconsistency problem occurs. This is where synchronization comes into place. okay, comes into picture. It will synchronize this whole process. Let's see some points for this. So if multiple threads are trying to operate simultaneously on the same Java object, then there might be a chance of data inconsistency problem. Okay, then to overcome this problem, we should use synchronized keyword. This is a keyword that is provided to us by Java. We will see in the code also. Now, synchronized is a modifier applicable only for methods and blocks. Okay, for a block of code or for the method, only for these two the synchronized can be used. It is not applicable for classes and variables. Fine. Next point is, if a method or a block is declared as synchronized, then at a time only one thread is allowed to execute that method or a block. This is what we wanted. If the method is declared as synchronized, that only at a time only one thread is allowed to execute that method or block on the given object. Okay, other threads need to wait for their chance, so the response time decreases. It is recommended to use synchronized keyword only if required. Since the response time decreases because of synchronization, so it is recommended to use synchronization keyword only if required. Let me explain this whole steps in the example. So now, for example, if I have a class comma ABC, and if I have a method, for example method 1, okay, now this is my class, this is my method, and what happens is T1 T2 is coming and they want to access it. So to access it, we have an object, obviously class object. So we have an object, and in this object we have a method, that is in this class we have a method m1, okay, and T1 and T2 wants to access it. So since there is no synchronized till now, they can both access it. They can both simply access m1. Okay, and if in m1 we have only read operations, then there is no problem. But in m1, if we have an update operation, delete operation, that is we are manipulating some kind of data, then there is a hell of a lot of problem, because T1 and T2 both can update and manipulate the data simultaneously, and this will cause the data inconsistency problem. So you have to take care of these steps. Okay, now if I use synchronized in this method, then at a time only simply single thread is allowed to execute method 1. Okay, to execute method 1 only single thread is allowed. Now how that will happen? Every object in Java has a thing known as lock. Okay, so when we use synchronized keyword, now this ABC, if T1 comes, T1 will acquire a lock. On ABC, and it can execute method 1. Now when T2 comes, ABC will tell, see, my lock is with T1, so you cannot execute synchronized method M1. So T2 will go into a waiting state. Okay, when T1 completes, so it will send ABC that I'm complete. ABC will tell T2 that yes, my lock is now available, you can now have it. Okay, then T2 can execute the synchronized M1 method. So synchronization actually is implemented inside using the logs. Okay, let's see these points. Internally, synchronization concept is implemented by using lock. Every object in Java has a unique lock. I've told these points. Whenever we are using synchronized keyword, then and only then lock concept will come into picture. Okay, if a thread wants to execute synchronized method on a given object, first it has to get the lock of that object. Okay, these are the points that I just explained. Once thread got the lock, then it is allowed to execute any synchronized method on that object. Okay, if not just M1, if I have synchronized M1, synchronized M2, synchronized M3, these are all present in an object ABC, and I have a lock of ABC, then in this case I can execute M1, M2, M3, all the three methods. Okay, once method execution completes, thread release the lock automatically. Okay, once the method execution completes, so thread will release the lock of ABC. Fine. Acquiring and releasing the lock is internal, and it is done by JVM. So as a programmer, we do not have to take care of this part. Okay, just we have to know how this happens internally. We do not have to take care of it. It happens automatically, and it is taken care by JVM. Fine. So let me give you some example now. So for example, I have a class ABC. Fine. Then I have a method. I have a synchronized method M1. I have a synchronized method M2, and I have a normal method M3. Okay, so I create an object of my class, and these three methods are present inside of it. Now T1 arrives. And he says, I want to execute M1 method. So ABC will say, okay, no other request is pending, so I will give you my lock. So he gives the locks, and here it will T1 start executing M1, correct? Now T2 arrives. T2 arrives and T2 says I want to execute M1. But ABC will say my lock is with T1, so you have to wait. So T2 enters the waiting state. Fine. For example, T3 arrives. Now T3 wants to execute M2. T3 wants to execute M2. So this was M1 method, so you might have understood that by it gone to waiting state. Now what will happen to T3? Will it be allowed to execute the method, or will it be went to the waiting state? Will it be sent to the waiting state? Come on, think. What will happen to T3? Will it be allowed to execute or not? Think about it. Since M2 is also a synchronized method, so T3 will require the lock of the object. So T3 will require the lock of the object. But the lock of the object is currently with T1. So do not require the lock of method. We require the lock of object. There is nothing known as the lock of a method. Okay, it requires the lock of the object. But the object lock is with T1. So ABC will say the same thing to T3 that go to the waiting state because my lock is with T1, correct? T4 arrives and he says I want to execute M3. Now think what will happen. Will it be able to execute M3, or will it be sent to the waiting state again? Just think about it. Pause the video and think about it. Okay, so I hope you pause the video. So what is happening here is M3 is not a synchronized method. M3 is not a synchronized method. So we do not need, a thread do not need any lock to execute M3. Thread do not need any lock to execute M3 since it is not synchronized. So it will be allowed to execute M3. T4 will be allowed to execute M3. Now I hope you understood how synchronized method works. Okay, this was an example to explain you how synchronized method works. Fine. Next, we will see these points that if a thread is executing a synchronized method, for example, the T1 was executing M1 method on a Java object, then remaining threads are not allowed to execute any synchronized method. Okay, this is important. For T1 is executing M1, but T3 was also blocked to execute M2. So because M1 and M2 both were synchronized, so no thread is allowed to execute any synchronized method on that object simultaneously. Threads are allowed to execute any number of non-synchronized methods. For example, we have M3 which was not synchronized, therefore this can be executed even if the lock is present or not present. It does not matter, because only if the synchronized keyword is written, then and only then the lock concept comes into picture. This point was also given to you previous slides. Okay, whenever synchronized keyword is used, only and only then lock concept comes into picture. Okay, if synchronized keyword is not used, for example in this case synchronized keywords were not used, therefore you do not need any lock to execute M3, correct? So this was the case. Now let's see some code. Okay, now we will see some code and we will move forward in synchronization after that. So this is the template for our example. So we have animal names class, we have a myThread class, or you can say a child thread class, and you have a synchronized demo class. Okay, so in the class of animal names, we will have our synchronized method. We will have a synchronized method. Okay, synchronized void print name, and here we will pass our string name. Okay, fine. Then here in this we will have a for loop for int I equal to 0, I less than 5, I plus plus. Okay, and in here we will have system.out.println. Simply animal name is, and the name that we got through the parameters. And I want to sleep for some time, so thread.sleep of 1 second. Now sleep, whenever you are using sleep, you have to catch the exception, so add exception there. Fine. So this is a normal animal class. Now since I'm using synchronized, at a time only one thread will be able to use this. At a time only one thread will be able to access this method, that is print name method. At a time only one thread will be there. Fine, we will see how this will happen. Now in my thread class that extends my thread, so we will use animal names an. This is the animal name, that is nothing but my class name, and this is a reference variable an, correct? Now string name. After this I will create a simple constructor. Okay, simple constructor. So animal names and comma string name. By now you should be very comfortable with constructors. Okay, so this dot an equals to an, and once again name, this dot name equals to name, this dot name equals to name. Let's see now. Since I am extending the thread class, I have to write the run method. So public void run. Okay, I have to override the run method. I have explained this in detail. Now I need a try catch block here. I will explain you why. So an dot print name, and I will pass the name that I have got it. Okay, now see, this was the reason why I routed try catch, because he is saying that at catch clause, that is interrupted exception. To handle the interrupted exception, I am doing this. Okay, no need to print anything. So why here interrupted exception is needed? Because I am calling the print name, and print name contains a sleep method. Okay, here it is catching, but here also it needs to catch it. Therefore, this whole process takes place. Fine. Now I am going into my main method. In the main method, all I have to do is I have to create animal name variable, instance, what do you say, reference variable, animal names, name equal to new animal names. Okay, then I have to create my thread, t1 equals to new my thread, and here I will pass the values. That the object is name, and the value is cat. Correct. Then I will create one more thread now, t2 thread, here new, and here I will pass the object is same, object is not different, object is same, that is name. Okay, and I am passing dog. Correct. So, and t1 dot start and t2 dot start. Fine. So both are starting now. So how many I have now? Threads total, I have 3 threads, the main thread and the t1 thread and the t2 thread. Okay, now t1 and t2 both are operating on the same object, that is name. See, name is an object, a reference variable initialized here, object is initialized here. Say name is an object. Correct. So the t1 and t2 both are accessing the same object. Okay, and they are passing the value as cat and dog. Now when I come here, the object is name, and they are both trying to access the same method, that is print name, but the method is synchronized, so they both cannot have the access to the synchronized method at the same time. So what will happen? Only one thread is allowed to access the synchronized method, that is print name method. Okay, it can be t1 or it can be t2, we do not know that, but only one. So if it is t1, cat will be printed first 5 times and dog will be printing second 5 times. But if t2 got the chance first, then dog will be printing first and cat will be printing second. So we know who got the chance first by using these names. Okay, so let's see, I have run it. So animal name is cat, so cat got the chance first, means t1 got the chance first, then t2 will go, and using the sleep there is 1 second gap. Okay, so it can change, actually I do not know it will change or not, but it can change because it depends on the compiler, it does not depend on us. Correct. I have explained you this process, this thing, that it depends on the what you say thread scheduler. It does not depend on it, can give cat every time to this t1. Okay, t2 chance will come afterwards. Fine. So it completely depends on the thread scheduler. So if I remove the synchronized one, if I remove the synchronized keyword, now both can access it simultaneously. Correct. Now both can access it simultaneously. Now I do not guarantee the output. Now it can be anything. As you can see, it's dog first, cat second, cat first, dog second. Now it can be anything. Now it is not dependent on us, it is dependent on the thread scheduler. Okay, but if I use the synchronized keyword, at a time only one thread is allowed to execute the print name. So you have seen the differences between the 2 points, that when I use synchronized and when I deleted synchronized, what is the difference? Correct. So this was synchronization, the synchronized keyword. This is how you use synchronized keyword in your code. We will see many more points on synchronization. Fine, let's do some modifications, just a bit of modifications now in our code. So for example, what I'm doing is I'm changing the objects. Let's say this is animal names b name. So now I have 2 objects. Is no one object but 2 objects. Okay, a name and b name. So t1 is calling on a name and t2 is calling on b name. Okay, 2 different objects. Now what will be the output? Will it be a regular output, that is cat will first, dog will be second, or will it be a mixed output, irregular output? So what do you think will happen if I change this? Will it be a regular output or won't it be a regular output? What do you think? Now what is happening here is we have 2 different objects. We do not have a single object, but we have 2 different objects. For example, now what is happening? I have a name object and I have a b name object. There are 2 different objects. Okay, now t1 wants to execute the print name on this object and t2 wants to execute print name on this object. So it will get the log of this object and this will get a log of this object. Okay, and they will be able to execute m1, and this also will be able to execute print name. Correct. So both will be able to execute print name simultaneously now also. Okay, So what is happening here, because there are two different objects, therefore this issue is happening. Okay, because now T1 is getting a log from this object and T2 is getting a log from the second object, correct? So synchronization is required if multiple threads are operating on the same object. Just keep this in mind. Synchronization is required if multiple threads are operating on the same object. This is very important. If threads are operating on multiple objects, then synchronization is not required. If they are operating on multiple objects, then it is not required, because now what we are doing here is we are operating the threads on multiple objects. Here synchronization is not required. But if we are in the previous example, we have seen it was the same object. If I change this to A, then it is the same object, correct? Now we know what synchronization will do. Okay, it will give power to one thread, it will completely execute it, then the T2 will be executed. Let's see, for example. Correct? So this was a very important point. Just take notes of these 2 points. Synchronization is required if multiple threads are operating on same object. If threads are operating on multiple objects, then synchronization is not required. Fine. Let's make a small change again. Let's do a small change again. What if I use static keyword here? Just a small change. Now what will happen? Now we are still using two different objects. Not a single object, but we are still using two different objects. Now what do you think what will happen? This is a new concept. Let's see. We have a A name and we have a B name. That is two different objects, correct? Now we are using static synchronized method. Static synchronized, correct? Just keep that in mind. T1 and T2 are my two threads. He wants to execute print name, he also wants to execute print name, but now the print name function is not synchronized function, it is a static synchronized function. So what T1 and T2 needs are not the object level log but a class level log. Okay, just keep this in mind. It needs a class level log. There are two levels of log, class level of log and object level log. Okay, so in the case where I use static synchronized before my method name, so in those cases the thread needs not an object level code but what class level logs. So it will have a class log. What is my class name? Was, I think, animal name, correct? So it needs animal name log T1. If T1 gets it, T2 won't be able to execute the print main. Okay, so this is the case. So let's see here, I have two different objects, so the answer should be mixed, but since I am using static, now it needs a class level log, so the answer will not be mixed, it will be a regular answer. Okay, so this was the difference. So whenever I am using static sync, the thread needs class level log. Whenever I am using the synchronized method, the thread needs object level log. Okay, there are two different points. Fine. So if a thread wants to execute static synchronized method, then the thread requires class level log. Similar to object, every class in Java has a unique log. Class also has a unique log. Okay, similar to objects, every class in Java also has a unique log. Okay, so I have explained you this, that there is a class level log and there is an object level log. Okay, so if I am just using synchronized keyword, object level log is required, but if I am using static synchronized keyword, class level log is required. I think it is very clear now. It should be very clear by now, I think. So just take this example now. So we have a class ABC. Okay, I have a method static synchronized, this whole synchronized, then method A1. Okay, then I have static synchronized method A2, then I have here sync A3, sync A4 and normal A5. Fine. So these are my class and these are my methods. So I have an object of ABC. Now what do you think will happen to everything? Now let's say T1 comes first, right? I want to execute A1 method. So which log do I have to give it? A class level log or an object level log? Just think about it. Which log do I have to give? Class level log or object level log? You have to give a class level log, class level log of my class ABC. Fine, you have to give a class level log to T1, so it will start executing A1 method. Now if my T2 arrives, and he wants A2, he wants to execute A2, so will it be able to execute it? Or not? Just think about it. Will it be able to execute it or not? It won't be able to execute it. The reason being, it is also a static sync method, so T2 also need a class level log, but the class level log is given to T1, so it will be sent to waiting state. Okay, now come to T3. T3 wants to execute simple A3. Will it be able to execute A3 or not? Just think about it. A3 is not a static sync, it is a sync, so it needs an object level lock, not a class level lock. Object level lock is still available with ABC, so it will give T3 the object level lock of ABC, correct? So T3 will start executing A3, correct? Now T4 will come. T4 wants A4. Will it be given? Now it should be very simple. A4 will not be executed by T4. The reason being it needs an object level lock. T4 needs an object level lock, but it is present with T3, so it won't be given. So now T5 comes and he wants A1. So will it be possible for T5 to get A1? Just think about it. Will it be possible for T5 to get A1? No. Why? It needs a class level lock. For A1 it is a static sync, so it needs a class level lock, so it will be sent to waiting state. T4 will be also sent to waiting state. Comes T6 and it needs A5. So since A5 is not sync or not static sync, so it does not need any kind of lock, so it will be simply executed. Okay, T4, T2, T4 and T5 will be waiting, and T3, T6, T1 will be executing. So this was synchronization. I hope you understood what this synchronization is. Okay, how you use synchronized keyword, what is static synchronized keyword, and by this example I think it should be really clear about the synchronization concept. Okay, so now in this video only, let's see synchronization block. It's just a 4-minute lecture. Just 4 minutes I will take for the synchronization block. Okay, we will complete this in this video only. So what is synchronization block is, you know synchronization method now, correct? So if my method, for example, I have a synchronization m1 method, and this method contains, for example, many lines of code. For example, 1 lakh line of code. Okay, but in actuality the updation is occurring only in 50 lines. It has a 1 lakh line of code, but in only 50 lines the updation is occurring. So the shared variable is accessed only in these 50 lines. Why do we need to say the whole method is synchronized? Okay, so why the whole method needs to be synchronized? In that cases we will use synchronized block. Now what will be the importance of synchronized block is, the threads will not be the threads will be able to access m1 simultaneously. Threads will be able to access m1 simultaneously, but only those for these 50 lines these threads will execute one by one. Only for these 50 lines these threads will execute one by one. Okay, so let's see here. After these 50 lines again they will be able to execute simultaneously. So only for these 50 lines they will be executing one by one. So the response time will increase. Correct? And what will happen? Our synchronization will also be able. So the response time will increase. So this is the importance of synchronization block to the normal synchronization. This is a method. Okay. So if only 50 lines is needed, then only 50 lines are synchronized, and all the remaining method is same. So what is the point? If very few lines of code require synchronization, then it is not recommended to declare entire method as synchronized. We just have to enclose those few lines of code in synchronized block. Okay. The main advantage of synchronized block over synchronized method is that it reduces the waiting time of the thread and improves the performance. Okay, response time increases. So this is one type. This is known as critical section where updation occurs. Okay, so if I write synchronize this, so what is the meaning of this is, if a thread got log of the current object, so if the thread get log of the current object, then only it is allowed to execute this one. Fine. Next point is, if a thread get log of a particular object, then only it is allowed. So for example, I have ABC one object and another object of the same class, ABC1. Okay, now T1 comes to ABC and it has a log of ABC1. So if I am writing this here, I write ABC1. So what will happen? These lines of code will be able to execute. This lines of code will be able to execute because T1 contains the log of ABC1. So if a thread got log of a particular object, then it is allowed. Next point is for the class level log. So if a thread got a class level log of a particular class, then it is allowed to execute this area. So there are three types of synchronization blocks: one for a class level log, one for an object, for a particular object, and one for the current object that is executing. Okay, class level for a particular object and a current object. So we have seen actually so many collections, correct? We have seen many collections classes. So which of these collection classes are synchronized, which are thread safe, which are not thread safe? Let's see that. Just 2 points. So by default, hash table, vector, and stack classes are synchronized. Okay, so these are nothing but legacy classes. In the collection framework video, we have seen hash table, vector, and stack are legacy classes. Only those classes are synchronized, that is thread safe. Rest all classes like array list, linked list, hash set, hash map, tree set, they are not synchronized. They are not thread safe.
They can be become thread safe by external methods, but they are not internally by default thread safe. Okay, only hash table, vector, and stack are thread safe. Fine. After this, now we can go to inter-thread communication.